So today we continue to work on equations. I continue to emphasize these same points. There's an equation that's like a scale. So whatever we do to one side, we have to do the same thing to the other to keep it balanced. We're looking to focus on the variable. We love the variable eventually to be alone. So whatever's with the variable, we're going to do the opposite. And when we're done, we can check answers. For these, you might notice the problem's got a little bit bigger. I call these on the paper and on the notes two-step equations. So you have a paper and notes where you have the same problems on the board that I have. I made a small mistake. I ended up putting this on the paper twice. I'm only going to do this one once. It's the last one of this column and the top one of the next column, so I'm not going to do that twice. And then there's a homework sheet that says two-step equations on it. When you have two steps to do, it does matter the order that we do them. We had this conversation the other day where we looked at this problem. That was an argument-inducing kind of question. 2 plus 3 is 5. 5 times 4 is 20. A lot of people would think that's right, and it's not. There was a thing called the order of operations that we had to do multiplying before we did adding. 3 times 4 is 12. 12 plus 2 is 14. We learned that day about the fact that the order that you do a problem does matter. So when we go to look at this problem, the variable's multiplying 2. The variable's also adding 6. So at some point, because of the add 6, we're going to have to subtract 6. At some point, because of the multiply 2, we're going to have to divide 2. We're going to have to do 2 opposites. The order does matter. If we were here in person, I would get another argument going where almost everybody would be saying we should divide first and save the adding and subtracting for last because the order of operations told us to save adding and subtracting for last. Unfortunately, you'd all be wrong because when we're doing these equation solving problems, it's not just about doing the opposite things, we're also going to need to often do them in the opposite order. So adding and subtracting today just got promoted from last place to first place. So when we do this board full of problems today, we're always going to do the adding or subtracting part of it first and save the multiplying or dividing part of it last. There's no powers involved today, there's no parentheses involved today, and someday we'll get into those things, not as 7th graders, but as 8th and 9th graders together. But for now, today, just run the order of operations opposite. We're going to go add, subtract first, multiply, divide second. So since this is adding 6, I'm going to subtract 6 to eliminate that. I'm not going to subtract 6 here because that is still on the same side of the equals. Don't touch this yet. If we're going to subtract 6 on the left of the equals, subtract 6 on the right of the equals. We'll draw our line as always, but this time there's more to bring down. Every other day it was just an x that was left. Right now there's 2x still left. Equals is there, 14 minus 6 is 8. And now where we usually have been done other days, we're only halfway done. We're going to do the adding or subtracting first. Now we're going to do a multiplying or dividing to finish. This is multiplying 2. So I'm going to divide by 2's. Eliminate the 2's. Now it's just an x that's left. Now we're done. This will equal 4 if we divide correctly. And we'll go the same theory as yesterday. If it's a whole number, let's check it. Put the 4 where the variable started from. 2 times 4 is 8. 8 plus 6 is 14. That checks. For this one, I'll skim first for the adding and subtracting. Adding and subtracting first. I see a subtract 7, so I'm going to add 7 to get an elimination. And then I'm going to add 7 on the other side of the equals to get myself an 18. Equals is still there, and I'll bring this down unchanged. 3x is still there. Since 3 is multiplying, now I'll divide by 3's. Eliminating 3's, leaving an x alone, so I'm done. Dividing that gets me 6. Checking, 3 times the 6 I just said is 18, minus 7 is 11, that works. Here I'm going to subtract 7's to eliminate 7's. not changing 5 or x or equals. Math there gets me a 16 if I subtract right. Now I'm going to divide by 5s to eliminate 5s. X is alone, so now I'm done. 16 dividing 5 is 3. There's 1 left over for a remainder when you do that. 5 into 16 being 3. 3 times 5 is 15. 1 left. Remainders on top. And just leave the 5 on the bottom. If it's not a whole number, I don't care if you check it. We could check it. You could take 5 times this. 5 times this would be 16. Adding 7 would be 23. It would work, but I'm not going to make you do that if there's fractions involved today. Seeing a subtract 6, I'm going to add 6 to eliminate the 6, and then do that on the other side of the equals. You're never going to touch the xy thing at first. The 4x is going to stay, the equals is going to stay, adding gets me 22. Since 4 is next to the x, it's multiplying, so I'll divide by 4 to get that crossed out. 4 into 22 goes 5. At first, the remainder would be a 2 on top of a 4, but that'll reduce down to a half. This, I'll subtract 2 to eliminate 2's. Subtracting 2 changes this side into negative 12. Negative 3x remains. So I'll look to divide. Not just by 3, but by negative 3. The negative and the 3 are traveling together. Don't lose sight of the fact these are all negative 3's the whole way through. And this is a negative 3 over there also. Just an x is left. 2 negatives makes a positive, and divide gets me a 4. We can check whole numbers. Negative 3 times 4 is negative 12. Negative 12 adding 2 is negative 10. That does work. Subtracting 7 makes me add 7 to eliminate. Negative 4 is still with the x. When a negative adds a positive, that's a negative when the negative's bigger, and we subtract them when they're different to get 13. Then I'm going to divide by a negative and a 4. Keep the 4 and the negative together. Everywhere there's a 4, there's a negative with that 4. They travel together. Eliminating them there leaves me just an x. 2 negatives is a positive. 4 into 13 is 3. Put 1 for the remainder. Leave 4 on the bottom. This one I'm going to subtract 8 to eliminate 8's. Over here I'm subtracting 8's, which also either eliminates the 8's if you want to think of it that way, or it makes a 0. 8 minus 8 is 0. The negative and the 5 and the x are still there, and then we look to divide. Negative and 5 are together doing the dividing and the eliminating. Over here it's negative 5. X is alone, and it would equal 0, because 0 dividing anything is 0. Once you get 0 in the middle of one of these problems, it's kind of like a black hole of math. Once you get 0, you're just going to sort of be stuck with 0. We can check that. Anything times 0 is 0, and if that adds 8, it is 8. That does work. Add 4 makes me subtract 4 on this one. Eliminates the 4's. 9 minus 4 is 5. Keep the x and the negative 10 all together unchanged. Never change the whole area around the x, the multiplying area at first. Divide at the end. To get rid of negative 10, we'll have to divide by negative 10 to get an elimination going. It's negative because there's 1 of each. And then 5/10, 5 is too little to divide 10, so just think of it like a fraction. 5/10 reduces to a half. Here's another thing that's probably good to know, I'll just throw out there. If I want to write negative a half, I have 3 ways I can do that, and it doesn't matter which way I choose. If I want to take this fraction and make it a negative fraction, I could either do a negative on the top, or I could do a negative on the bottom, or I could just put a negative out in front of the whole thing. Those 3 all mean the same thing. So it doesn't matter where you have the negative, it just needs to be in there This problem has a small change because I've started to use the fraction bar to divide. There's no multiplying on my board, there's dividing on my board. But our strategy remains the same. Add or subtract first. So with the subtract 6, I'll add 6 to eliminate. Add 6 over here to get a new creation. If negative 4 adds 6, that's positive 2. And I'm going to leave this x dividing 3 part the same way it was. I'm never going to change that small area around the x. Since that's dividing 3, I will multiply 3's to eliminate 3's. X alone would equal 6. I should be able to check that. That's a whole number. So 6 dividing 3 is 2. 2 minus 6 is negative 4, and that checks. Look for adding and subtracting first. I see an add 3, so I'll subtract 3. Eliminate 3's. Leave this x area of division unchanged. If negative 8 subtracts 3, that's down to negative 11. Since I still see dividing, I'll multiply negative 2's to eliminate negative 2's. Make sure every 2 has a negative sign with it. That's just, they're stuck together. Finally, x is alone. It's positive 22 for an answer. Multiplying is 22, but when the signs are the same, it's positive. I can check, let's check whole numbers. We'll check whole numbers on the homeworks. 22 dividing negative 2 is negative 11. If negative 11 adds 3, it is negative 8. If you haven't tried any for yourself, pause the video, try these last 2. Make sure you can do this before you try the homework on your own, and then you can unpause it and see if you did what I did. What I'm doing here is I'm first going to find the adding or subtracting. So I'm going to look to add 8 to eliminate 8's. Add 8 also to the 10, because that's on the other side of the equal sign. That makes 18. And this xy thing is just going to copy down. Negative and 3 and x is just copying. This was a little different because the variable was on the right, but it doesn't change our strategy. Find the adding or subtracting first. Now the negative 3 is multiplying, so I'll divide, but not just with 3, but keeping a negative with every 3, because they're locked together. Eliminating 3's, x is alone, dividing there is a 6, but it's a negative 6, because when signs are different when we divide, it's negative. Checking it, negative 3 times negative 6 is a positive 18. 18 subtracting 8 is 10, so that checks. And then for the last one, I find my adding or subtracting area and do the opposite. I see an add 11, so I'll subtract 11 to eliminate. And I have to do the same thing on the other side of the equals. I'm going to copy x, and its multiplying or dividing thing is always not changing at first. 5 minus 11 is negative 6, because 5 is too little to subtract 11, it goes negative. I see divide, so now I multiply with negative 7. The negative and the 7 are stuck together. Eliminate the 7's. Variable is alone, so I'm done. Negative times negative is positive. 6 times 7 is 42, and we can check that. 42 dividing negative 7 is negative 6. Negative 6 adding 11 is positive 5. That does work. And we're good. Try the homework paper. Let me know if you have questions.